Hello, welcome to my channel. You can find the worksheet below this video. Let's start our lesson. Number lesson 4, radicals. Today we will discuss 3 parts: radicals, square roots, and cube root. First, let's see what is radical. The number like square root 30, cube root 35, or maybe fourth root 460 are examples of radicals. And normally radical write in this way, and we see this n is index and x is radicand. And this one is radical sign. For example, like so the number 3 is index and 35 is radicand. Okay, and normally, and if you see only a radical sign without any number, so this means this is square root. Okay, let's move to square roots. And all positive number have 2 square roots, a positive number and a negative number. And because, for example, if we have square root 4 is equals to positive and negative 2. Because positive times positive equals 4, and negative 2 times negative equals 4, the same. So this is why it has a positive and a negative number. The positive square root is called the principal square root and is denoted by simple this. The square root of a perfect square are rational numbers. The square roots of a non-perfect square are irrational numbers. For example, like square root 4 and is equals to positive and negative 2. So this is a rational number. But last class we discussed about square 2 and equals to 1.41421 So this is non-terminating numbers and non-repeating numbers. So this one is a irrational number. Now let's see how to determine the perfect square. The prime factorization of a prime square will involve factors which occur in pairs. If the prime factorization of a number doesn't impair all factors, then we can say that the number is not perfect square. Okay, let's see, the first example is 216. And we use the prime factorization and to solve this one, and we got 6 and we got 36. For this one we got 2 3 and we got 6, we got 6 and we got 2 3, we got 2 3. And then we can see, because we need a pair, so we have one group of 2 3, the second group of 2 3, and the third group of 2 3. So we have 3 groups. It's impossible to make a pair. It's impossible to make in pairs. So this is not a perfect square. Next example is 1225. So we divide into 5 and 245 and 5. We divide 49 and 49 can be 7 and 7. We can see the the prime factors are 5, 5, 7, 7. So we can make one group is 5, 7, and it has two pairs. So this one is perfect square, and the square root is 35. 5 times 7. Last one is 11025. So we can separate as 5 and 2205. We can divide 5, and 441 we can divide to 3, and 147, and then we can divide into 3 and 47, and then 7 and 7. And in this way we can see that factors in pairs. So we have 2, 3, 2, 5, and 2, 7. So this is a perfect square, and the square root equals to 3 times 5 times 7 equals to 75. So this is the square root. Okay, let's discuss about cube roots. And all numbers have one cube root, denoted by the symbol like cube roots, like this one. The cube roots of a perfect cube are rational numbers. The cube roots of a non-perfect cube are irrational numbers. For example, like cube root of 27 equals to 3, and 3 is a rational number, so this one is a perfect cube. And cube root of 5 equals to 1.7099759, and with infinity, and this one is a non-terminating number. Also, this is a non-repeating number, so this one is an irrational number, and this one is a non-perfect cube. Determine the perfect cube. The prime factorization of a perfect cube will involve a set of factors which each occurs 3 times. If the prime factorization of a number doesn't result in factors which occur 3 times, then we can say that the number is not perfect cube. Let's look at some examples. And the examples we use for the perfect square is 216, and we have 6, 36, and 2, 3, 6, 6, 2, 3, 2, 3. Now we have 3 group of 2, 3, or we can see we have 3, 6, like 3 times. So this is a perfect cube, and the cube root is 6. Next example, we have 6,912, and this time we use division table. And this one we can divide 2, and it equals to 3, 4, 5, 6. And then we divide 2, and we got 1728. We divide 2, and we got 864. We divide 2, we got 432. We divide 2, and 2176. Divide 2, and we got 108. We divide 2, and we got 54. And now we can still keep divide 2 and 27, and then we can change to 3, and 3 and 9, and 3, and this is 3, and 3 again, so this is 1. And then we can see, and we have how many? 2, 1, 2, 3, 4, 5, 6, 7, 8. We have 8, 2 times 3. We have 3, 3. And in this way, because we have 8, it's impossible to make like divide 3. So this one is not a perfect cube. And the last one is 4, 2, 1, 875. Okay, so the first we can divide 5. That is 8, 4, 3, 7, 5, and we try 5 again. And we try. And now we can try 3, 9, 3, 3, 3, 1. Okay, and this way we can see, and for 5 we have 1, 2, 3. So and then 5 we have 1, 2, 3, and 3 we have 1, 2, 3. So everything occurs 3 times, so it's 3 times 5 times 5, and this is a perfect square, and the root is 75. So this is the cube root. Thank you for watching. If you like my teaching, please click the subscribe button. Please let me know your questions in comments.